In this example, we're going to express x plus 1 over x minus 2 squared in partial fraction. For the first step in doing partial fraction, we have to make sure the fraction given here is proper. So let's see, numerator here is linear. So if we expand the denominator here, we can notice that this is square, so this is quadratic. So you can see linear is smaller than quadratic in the term of power. So means that this fraction given is proper. So second step, we're going to make sure the divisor here or our denominator here is in factor. So for this, x minus 2 means x minus 2 squared. So the denominator part is in completely factor. Then we can start our partial fractions. So for these partial fractions, step number 3, we're going to split its factor. So you're going to split into a smaller fraction. To a smaller fraction means the partial fractions. So how we're going to split here will according to the factor that we have in denominator part. So you can notice that denominator part is a linear factor, but it is repeating. X minus 2, x minus 2, they are same. They are repeat two same factor. So the way to express in partial fraction, it will be for the first time, for the first partial fraction, we will write the first factor, which is x minus 2. Then we will repeat again, because this one we repeat two times. So for the first time, we just write x minus 2. So when we repeat again, we are going to do x minus 2, x minus 2. Or I can write it in better way. I will write it x minus 2 squared. So this is how we meet the situation having a repeating factor. So the first time we write it once, the second time we write it twice. So in the power here, power of 2 means we know this is repeating twice already. After that, so this is step number 3, how to split the factor into the partial fraction. Step number 4, we're going to determine what is your A or linear here, what is the constant here. So as we can see, this is linear factor, means up here must be smaller than linear. It will be a constant A. So when we move to here, repeating factor, you'll notice that this factor is repeating, but inside here, it is considered a linear because x is to power to 1 is considered linear. So therefore, for repeating factor that repeating twice, so we will consider inside the bracket here, what is inside the factor here. This is called linear factor. So for numerator, we have to find something smaller than linear, so it will be a constant b. So after that, we're going to form out the equation by equating the denominator. So we will show the numerator here for x plus 1. When this fraction combine back to its original fractions, so the A supposedly to multiply with x minus 2, because you can see it owns denominator here already having one factor. So what it need is just multiply another x minus 2 to go back its original fractions. So for B here, we have nothing to multiply because you can see its denominator is originally same as our original fraction. So it will be B. So the numerator part here only will be x plus 1 equals to A times another factor x minus 2 and B plus B only. So after that, we're going to find out what is our unknown A, B here. So notice that we have two unknown, so means we have to find it, let it twice, let the method finding twice. So let x to be any value. So we will more easier if we using the value is come from this factor. So let x equals to 2. When we substitute inside this equation, we will notice that this factor will give you 0. So you can straight away finding B. Then we have to let another time to find a. So this time you will notice that we don't have any roots, we don't have any factor that we can get the x value. So for this x value, we can randomly put any value. So let's say I randomly put a 0. Randomly put a 0. When I substitute here is 1. So of course, when I randomly put a 0, definitely my a and b still will exist. So when I put a 0 here, it will be a times negative 2. And then b. So b, I found it already. Then I substitute b is in value 3. So we find out what is our a here. So move the a to the left hand side to a. Then this one I move to the right hand side is 2. So a is equals to 1. Lastly, we substitute back the value of a and b so that our fraction, this fraction, can be expressed to be its partial fraction. So one of the partial fraction is 1 over x minus 2. Another partial fraction here will be 3 over x minus 2 squared.